Hello children, welcome to GNANA DEEKSHA concept-based digital learning. I am Prakasham Shetty, JL in Physics, TSWREIS Junior College, Chilkur, Rangareddy District. Let us all welcome to our new academic year. As we all know that this pandemic has not yet ended, we still have to stay at home to curb the spread of the virus, ensuring everyone's safety. So, in this uncertain testing times, we put forward to you these learning sessions. So, what do we generally do at home? We try to watch TV or use mobile or attend online lessons through Zoom or some other apps, or just have good sleep. And to make all this happen, what do we require? Current. Then what is current? Today we will discuss about current and the types of current we use and their terminology. Current. An electric current is a stream of charged particles such as electrons or ions moving through an electrical conductor or space. It is measured as the net rate of flow of electric charge through a surface or into a control valve. Look at this simple circuit. This circuit consists of a small bulb connected to a cell. In this circuit, when electrons move from negative terminal to positive terminal, at the same time, positive charges move from positive terminal to negative terminal via an electric bulb. In this bulb, electrical energy converted into heat energy and light energy. If Q is the charge flowing through the given surface area in time t, then current I is equal to Q by T. SI unit of current is ampere. It is represented by capital letter A. Its dimensional formula is capital I or capital A. Types of current. Number 1. DC current, also known as direct current. Number 2. AC current, also known as alternating current. What is DC current? Current having unique direction which flows from positive terminal to negative terminal via an external electric element is known as direct current. Then what is AC current? If the direction of the current in an external electric element changes alternately, whose magnitude changes with time and direction reverses periodically, is known as AC current. See these pictures. In the first picture, AC EMF is drawn against to time. In this picture, AC voltage is continuously varying its magnitude and direction with time. In the second picture, the magnitude of DC voltage it is parallel to time axis. It indicates that the magnitude and the direction of current in the DC circuit in the same direction. AC voltage, the voltage whose magnitude and direction change with time and attains the same magnitude and direction after definite time interval and varies like a sine function with time is called AC voltage, and the current driven by it in a circuit is called AC current. Here in this picture we can observe the symbol of AC source in an electric circuit. Instantaneous current represented by capital I. I is equal to I naught sine omega t, or I is equal to I naught sine of omega t plus pi. In the same way, instantaneous voltage represented by capital E. Capital E is equal to E naught sine omega t, or capital E is equal to E naught sine of omega t plus pi. In this equation, omega t plus pi is called phase. Let us look into the picture. In this picture, EMF voltage is drawn against two fans. It indicates a sine current. The first positive half of the cycle, the electrons in a conductor move towards the positive electrode of the conductor. During negative cycle, the polarity of the conductor reverses. As a result, electrons in the conductor move in the opposite direction. Voltage that varies like a sine function with time is called alternating voltage, and the current driven by it in a circuit is called alternating current. Look at the picture. This picture shows a simple diagram of AC generator which generates electric energy. AC generator, to get sinusoidal varying alternating current, a source is required which generates sinusoidally varying EMF. An AC generator converts mechanical energy into electric energy. EMF or current will be induced in the coil by a change in the loop's orientation or a change in loop's effective area by rotating the coil in a magnetic field. This method of producing flux change is the principle of operation of a simple AC generator. The basic elements of an AC generator are shown in the picture. It consists of three main parts, which a magnet, an armature with slip rings and brushes. Number 1. Magnet. It may be a permanent magnet or an electromagnet. The poles of the magnet face each other so that a strong, uniform magnetic field B vector is produced between the poles. Second part, armature. It is a coil generally moved over a soft iron core. The core increases the magnetic field due to its magnetization. The two ends of the coil are connected to two slip rings C1 and C2. The coil together with the slip rings can rotate in the magnetic field. The axis of rotation is in the plane of the coil but perpendicular to the magnetic field. Third part, brushes. Two graphite brushes B1 and B2 permanently touch the slip rings. As the armature rotates, the slip rings C1 and C2 slip against the brushes so that the contact is maintained all the time. These brushes are connected to two terminals P and Q. The external circuit is connected to these terminals. When the coil having capital N turns is rotated with a constant angular speed omega, the angle between the area vector capital A and the magnetic field vector capital B is at any instant t is given by theta is equal to omega into t. As a result, the effective area of the coil exposed to the magnetic field lines changes with time. The flux linked with the coil at any instant t is given by phi b is equal to NBA cos theta, that is equal to NBA cos omega t. From Faraday's law of electromagnetic induction, the induced EMF for the rotating coil of N turns is given by E EMF is equal to minus N d pi by dt. The magnitude of the induced EMF is capital E is equal to NBA omega sine omega t. In this equation, NBA omega is the peak value of EMF. It is represented by letter E0. The total EMF induced in the coil at any instant t is given by E is equal to E0 sine omega t. As the EMF varies sinusoidally with time with the angular frequency omega, time period capital T, where capital T is equal to 2 pi by omega. The maximum magnitude of the EMF known as peak EMF is E0. E0 is equal to sine 2 pi by capital T into small t. We know E is equal to E0 sine omega t is equal to E0 sine of 2 pi by t into small t. When t is equal to 0, then E is equal to 0. When t is equal to t by 4, then E is equal to E0 sine of 2 pi by capital T into t by 4, that is equal to plus E0. When t is equal to t by 2, then E is equal to E0 sine of 2 pi by t into t by 2, that is equal to 0. When small t is equal to 3t by 4, then E is equal to E0 sine of 2 pi by capital T into 3t by 4, that is equal to minus E0. When t is equal to capital T on completion of one complete cycle, then E is equal to E0 sine of 2 pi by capital T into capital T, that is equal to 0. If the instantaneous value of alternating EMF is E is equal to E0 sine omega t, then the corresponding instantaneous value of alternating current is given by I is equal to I0 sine omega t, where I0, E0 denote the peak values of current and EMF respectively. In this picture, AC EMF is drawn against the angle made by the coil in the AC generator. When small t is equal to 0, EMF equal to 0. On completion of 1/4th cycle, that is pi by 2 radians of angle, EMF will become maximum. At t by 2 tan, EMF will become 0. At this point, angle rotated by the coil in the circuit is pi radians. At 3t by 4 tan, EMF is become maximum in the reverse direction. On completion of one cycle at capital T tan, again EMF will become 0. Each cycle of AC consists of 2 off cycles. For one off cycle, the current is entirely positive, whereas during the next off cycle, the current is entirely negative. One complete cycle of alternating current or voltage is shown in figure. The instantaneous value of alternating current or alternating EMF may also be represented by I is equal to I naught cos omega t and E is equal to E naught cos omega t. The figure represents alternating current or alternating EMF as cosine function of tan. In this figure, at t is equal to 0, EMF is maximum. At t is equal to t by 4, EMF will become 0. At t is equal to 3t by 4, EMF will become maximum in the opposite direction. This picture indicates EMF as a cosine function. Mean value or average value of AC per off cycle. It is an arithmetic average of all the values of current in a sine wave for off cycle, either positive or negative off cycle. The value of current at any instant t is given by I is equal to I naught sine omega t. Hence, the mean or average value for off cycle is given by I average is equal to 1 by pi integral 0 to pi I dt. That is equal to 1 by pi integral 0 to pi Im sin theta d theta, because I is equal to Im sin theta. That is equal to Im by pi minus cos theta 0 to pi. That is equal to Im by pi minus cos pi minus of minus cos 0. That is equal to Im by 2 plus 1 minus of minus 1. That is equal to Im by pi into plus 1. Therefore, I average is equal to 2 by pi Im. That is equal to 0.637 Im amperes. Thus, the mean or average value of AC over positive off cycle is plus 0.637 I naught, and that over negative off cycle it is 0.637 I naught. It holds the same for alternating voltage too. So, average alternating voltage capital E bar is equal to 2 by pi capital E naught. That is equal to 0.637 E naught. That is equal to 63.7% of E naught. Root mean square or MS value of alternating current is represented by I RMS. The instantaneous current I may be positive or negative at a given instant t, but I square is always positive. So we calculate the average of I square over a complete period and then take the square root of it. This gives the RMS current. RMS current is the square root of the average of squares of all the instantaneous value of current over one complete cycle. Now, IRMS square is equal to integral 0 to capital T I square dt by integral 0 to capital T dt, that is equal to integral 0 to capital T I naught square sine square omega t dt by capital T, that is equal to I naught square by capital T integral 0 to capital T sine square omega t dt. Substitute the value of sine square in terms of cos 2 omega t. So that is equal to I naught square by capital T integral 0 to capital T 1 minus cos 2 omega t whole divided by 2 dt. That is equal to I naught square by 2 capital T into small t minus sine 2 omega t by 2 omega from 0 to capital T. Let us substitute the limits in this equation. So we get that equal to I naught square by 2t into capital T minus sine 2 into 2 pi by capital T into t divided by 2 omega minus 0 minus 0. I RMS square is equal to I naught square by 2t into capital T minus 0, that is equal to I naught square by 2. Therefore, I RMS is equal to under root of I naught square by 2, that is equal to I naught by root 2, that is equal to 0.707 I naught. Clearly, RMS value of alternating current is 70.7% of its peak value. Similarly, RMS value of alternating EMF is given by E RMS is equal to E naught by root 2, that is equal to 0.707 E naught. Mean value or average value of AC during complete cycle. The value of current at any instant small t is given by I is equal to I naught sine omega t. The average value of sinusoidal wave over one complete cycle is given by I average is equal to integral 0 to capital T I dt by integral 0 to capital T dt, that is equal to integral 0 to capital T I naught sine omega t dt whole divided by 0 to capital T dt, that is equal to I naught integration of sine omega t is minus cos omega t by omega whole divided by capital T. The lower limit is 0, upper limit is capital T. That is equal to minus I naught by omega t of cos 2 pi by capital T into small t limits 0 to capital T. that is equal to minus I naught omega t of cos 2 pi minus cos 0. Therefore, I average is equal to minus I naught omega t into 1 minus 1, that is equal to 0. So, the average value of AC current over one complete cycle is 0. Similarly, the average value of alternating voltage over one complete cycle is also 0. Form factor of AC. Form factor is defined as the ratio of RMS value to the average value of alternating current or voltage during off cycle. That is, form factor is equal to I RMS by I average is equal to E RMS by E average. But we know that I RMS is equal to I naught by root 2 and I average is equal to 2 I naught by pi. Therefore, form factor is equal to I naught by root 2 into pi by 2 I naught, that is equal to pi by 2 root 2, that is equal to 1.11. Peak factor of AC. Peak factor is the ratio of peak value to the RMS value of alternating current or voltage. That is, peak factor is equal to I naught by I RMS, that is equal to E naught by E RMS, that is equal to root 2, a constant. Power in AC circuits. In DC circuits, power is given by simple expression P is equal to VI. In case of AC circuits, there is some phase difference between voltage and current. Power in AC circuits is defined as the product of voltage and that component of the current which is in phase with the voltage. Thus, P is equal to EI cos pi, where E and I are values of voltage and current. Power factor, the quantity cos pi is called power factor. Instantaneous power, P instant. Suppose E is equal to E naught sin omega t, comma I is equal to I naught sin of omega t plus pi in a circuit. Then P instantaneous is equal to E into I, that is equal to E naught sin omega t into I naught sin of omega t plus pi, that is equal to E naught I naught sin omega t sin of omega t plus pi. Average or true power. The average of instantaneous power in an AC circuit over a full cycle is called average power. Its SI unit is watt shown by the letter W, i.e. P average is equal to W by T, that is equal to integral 0 to capital T P dt by integral 0 to capital T dt, that is equal to integral 0 to capital T P dt by capital T. W is equal to integral 0 to capital T E naught I naught sin omega t sin of omega t plus pi into dt. that equal to integral 0 to capital T E naught I naught sine omega t bracket sine omega t cos pi plus cos omega t sine pi bracket close dt, that equal to integral 0 to capital T E naught I naught sine square omega t cos pi dt plus integral 0 to capital T E naught I naught by 2 sine omega t cos omega t sine pi dt, that is equal to E naught I naught cos pi integral 0 to capital T sine square omega t dt plus integral E naught I naught sine pi by 2 integral 0 to capital T sine 2 omega t dt, that is equal to E naught I naught cos pi into capital T by 2 plus 0. So, average power over one complete cycle P average is equal to W by T. In this expression, W is the electric energy or rate of work done is equal to E naught I naught cos pi by capital T into capital T by 2, that is equal to E naught I naught cos pi by 2, that is equal to E naught by root 2 into I naught by root 2 cos pi, that is equal to ERMS IRMS cos pi. Therefore, P average is equal to ERMS IRMS cos pi. The component of current along the EMF is I cos pi. So, the component IRMS cos pi contributes to the power consumption, but the component IRMS sin pi does not contribute to the power, and it is called wattless component of current, apparent or virtual power. The product of apparent voltage and apparent current in an electric circuit is called apparent power. This is always positive. P apparent is equal to ERMS IRMS, that is equal to E naught I naught by 2. Summary. Current is the net rate of flow of electric charge through a surface area or into a control volume. Alternating current is that current or voltage that is whose magnitude changes with time and direction reverses periodically. The maximum value of current or voltage in an AC circuit is called its peak or crest value or amplitude. The value of current or voltage in an AC circuit at any instant of time is called instantaneous voltage.